welcome to another science lesson. We are doing week 2 of online learning this week, and I'm very excited to have a look at some non-Newtonian fluids. But before we do that, let's do some recap on solids, liquids and gases. Let's have a look at our lesson objective for this week. Our lesson objective is to identify the properties of solids, liquids and gases. And to be successful today, we need to name at least one property of a solid, one property of a liquid, and one property of a gas. I'd also like us to identify the properties of a non-Newtonian fluid. Let's revise. What is a solid? Particles in a solid are tightly packed, usually in a regular pattern. Particles in a solid will vibrate but cannot move past each other. Solids retain their shape. That means it keeps its shape. Now, of course, we do get exceptions, like clay, for example. That's a solid and we can mold its shape and change its shape. So remember, we can have exceptions in solids, liquids and gases. Let's have a look at liquids. Particles in a liquid are closely together with no regular pattern. Particles in a liquid flow and can easily move or slide past one another. Liquids assume the shape of their container. Let's look at gases. Particles in a gas are well separated with no regular pattern. Particles in a gas vibrate and move freely at high speeds. Gases assume the shape of their container. Right, now that we've looked at all of that, I've got 3 objects here, 3 states of matter here. First one is an apple. Which state of matter is my apple? Delicious. And you are right, it is a solid. The particles can vibrate if I heat this up, but the particles won't pass each other. And I won't change the shape unless I take some of it out like I just did. Very good. It's got water. We all know what this is, right? No, it's not a solid, it's a liquid. It's a liquid because it retains the shape of the container. So it stays in the same shape as the container. And if I pour this into a glass, it will be in the shape of the glass. It can flow or pour, and the particles do move past each other. So it's definitely a liquid. Very good. Remember to drink lots of water, it's healthy and very good for you. Then I've got another state of matter here. This is a gas. Did you see the particles move out of the can? Now we've got all the gas inside here. It's the only way we can keep gas together because the particles move freely. And the moment it escapes the can, it moves freely into the air. And if someone was to stand a meter or 2 away from me, in a few seconds they would smell the air freshener because the particles are moving in the air. Right, so we've got our states of matter here and some examples. Now I would like us to look at non-Newtonian fluids. Now I know I've mentioned this before in some lessons, so this is not new for all of you, but I wanted to have a little bit of fun today. So I have got some cornstarch in a bowl here, and I would like us to mix it with water. We're going to make a mixture with a liquid and a solid. Yes, this is a powder form, but it's definitely a solid. Because even though it's a powder, the particles are tiny, and it's definitely thousands and thousands of little solid particles together make this powder. Right, so we are going to pour a little bit of water into our cornstarch, and we're going to mix it until the mixture is like a fluid. You can already start to feel some hard parts. Right, we don't want to pour too much water in it, so you're going to get really messy today. Get stuck in and mix it. Oh, I can feel it's getting hard. It's getting hard. We need to add more water. Right. Now, as we mix this in, it's a very smooth powder, and we'll start to feel that it is becoming more of a liquid. Now, the reason why I'm making this is to show you an example of a non-Newtonian fluid. A non-Newtonian fluid is a liquid, a fluid, that behaves like a solid when we add pressure to it. Now, if we made a lot of this, it would even be possible for me to walk on it if I walked really fast. Because if I add a lot of pressure to the liquid, it behaves like a solid. So if I'm really fast, I'll be able to squish it together and it will feel like a solid. Now, I'd like you to explore with this at home if you can. The cornstarch is quite easy to get. I think I bought this at my local supermarket for about 2 dirhams. So it's quite easy to get. So if you can, I know with the restrictions of going out, it's not always easy to get to the shops. But when mom or dad goes again, ask them to buy you a packet of cornstarch and explore a little bit with a non-Newtonian fluid. If I squeeze it quickly, it actually feels like a solid. So it behaves like a solid when it's under pressure, but it flows, it pours, and it retains the shape of the container it's in. So it's definitely a liquid. And as I said earlier, we can sometimes get exceptions. So a non-Newtonian fluid is an exception of a type of liquid. So it's still a liquid, but it behaves like a solid when it's under pressure. I would like you to have a little think and maybe some research, do some research on different types of non-Newtonian fluids. I'll give you a few clues. Shampoo is also a non-Newtonian fluid. If I add pressure to it, if I hit it, it feels like a solid. And this actually came out really well because I'm hitting it quite hard with my fingers, and my fingers aren't going through. It actually feels like I'm hitting a solid. But it is a fluid, it's a liquid. So I'd like you to have some fun with it. Create a non-Newtonian liquid and see if you can play around. Remember, see if you can add some examples of other non-Newtonian liquids to your Google Classroom. Thank you for having fun with me, boys and girls. I hope you have a lovely week. Stay safe, stay awesome.